So let's do our first hypothesis test for the mean. This first example, let's notice the alternate hypothesis has a greater than symbol. All right, anything with either a less than or a greater than symbol in this alternate hypothesis is a one-tailed test. Now the less than is the easier problem. A greater than is only slightly harder than the less than. So we'll talk about what if this had been a less than as we do this problem. All right, so you wish to test the following claim at a significance level of alpha equal to 0.05, and we have that our mean is 84.1 is our null hypothesis, and the alternate is that the mean is greater than 84.1. We believe that this population is normally distributed, and we know the standard deviation is 10.7. We obtain a sample mean of 90 with a sample size of 16. So we want to know what is the test statistic for this sample. Now this goes back to the z-score we've been using quite a bit in the last sections in section 9.2. So let's go back to that z-score with this information that we have. Now this m that they've listed is really our x bar that we've had in the formula, and we're going to fill in, and then here's our mu 84.1, and here's our sigma and our n. So here's that formula. Let's fill in to get our test statistic. So we're going to have x bar is our 90 that looked like m in our problem. Mu is 84.1 divided by, on the bottom, sigma is 10.7 divided by the square root, and n is 16. All right, so I'm going to do top and bottom separately. So first 90 minus 84.1, that gives 5.9. And now I'll do the bottom, 10.7 divided by the square root of 16, which is 2.675. And then finally, let's divide these two out, 5.9 divided by 2.67. And that gives 2.20567. Okay, now I think we were supposed to round to how many decimal places? 3. So what we're going to report here then is we'll report 2.206. All right, so that's what's going to go into that first blank, 2.206. Now, what's the p-value for this sample? Now, let's remember this is a greater than. So we're going to look this up in Excel, but to find a probability for greater than, we have to subtract from 1. If this had been a less than, all we would have had to do was report what we're going to get in Excel. Since it's greater than, we're going to subtract it from 1. So I'm going to do equal norm.s.dist 2.206 true, and I get this decimal, and I'm just going to go ahead and copy it and paste it. So we are going to say, since it's a greater than, we're going to say 1 minus this number that we just got from Excel. Now, if it had been a less than, we would just have reported 0.986308 as our p-value, rounding to 3 decimals, of course. But I'll go ahead and do this calculation, and that's going to give us 0.013692. And let's round it. Now, if we're rounding to 3 decimals, it's 0.014. Let's just double check that it's, oh no, they want it to 4 decimals for the p-value, so we want to put 0.0137. So 0.0137. Okay, now let's compare this p-value. Notice, and if it helps you comparing numbers, just compare the first 2 decimal places. 5 is bigger than 0.1 or bigger than 1, and therefore this p-value is smaller than 0.05. So the p-value is less than our alpha, so we want this one. If a p-value is less than alpha, we're going to reject the null. Now, if you have trouble remembering these rules, there is a little handout that you can print off that will help with these as you're going along. So if you forget, okay, is it supposed to be alpha bigger than p or p-value smaller than alpha? That's on that sheet. So since the p-value is smaller than alpha, we reject the null. When we reject the null, we're essentially embracing the alternate hypothesis. We want to say there's enough evidence to show that the alternate hypothesis is true. And our alternate is that the mean is greater than 84.1. So if we look down here, we're looking for something that says we have enough evidence to show the mean is greater than 84.1. So let's see. There's sufficient evidence to warrant rejection of the claim that the population mean. No, we don't want to reject that the mean is greater. There's not sufficient. No, we have enough evidence, so that's not it. The sample data support the claim that the mean is greater than 84.1. There it is. That's the one that embraces the alternate that the mean is greater than 84.1.